What is LSD and how does it create its effects through a cell signaling pathway? LSD, or lysergic acid diethylamide, is an illegal, potent psychedelic/hallucinogenic drug that is most commonly orally ingested. It is most well known for causing vivid hallucinations, as well as intensified thoughts, emotions, and sensory perception. Symptoms can begin within half an hour and will usually last between 6 to 12 hours, but can last up to 20 hours. How does this happen? Well, we have to understand the signaling pathway that this drug tampers with. You may be familiar with serotonin. Serotonin, or 5-HT, is a neurotransmitter that carries messages between the central and peripheral nervous system. It regulates mood, sleep, digestion, and cognitive functions. In general, the cellular response from the reception of serotonin is the opening or closing of an ion channel, making the neuron more or less likely to fire. Serotonin indirectly changes the voltage of the cell. Serotonin signaling pathways are very complex. There are 7 different families of serotonin receptors. Most of them are G-protein coupled receptors, but one family is a ligand-gated ion channel. For the sake of this video, let's focus on the 5-HT2A pathway. Reception of serotonin will activate the G-protein GQ11. It will go on to activate phospholipase C, which splits PIP2 into second messengers diacylglycerol and inositol triphosphate. Protein kinase C will also be activated. IP3 will let positively charged calcium ions into the cell, increasing the voltage and making the neuron more likely to fire, while PKC has multiple functions, including ion channel permeability, enzyme activity, and gene expression. What happens when LSD comes into play? When LSD is ingested, it will primarily bind to serotonin receptor 5-HT2A. However, it also binds to most other receptor subtypes, as well as some dopamine and adrenergic receptors. LSD acts as a partial agonist, meaning that when it binds to the receptor, it generates a response, but only a fraction of that which serotonin creates. When bound to a GPCR, LSD will most often recruit beta-arrestins in the signal transduction pathway, rather than activating a G protein. It will also activate different phospholipase enzymes than the original pathway does, such as PLA and PLD. But, beyond the chemistry, it is still not exactly known why LSD has the effects it does. However, the most likely reason for why LSD's effects last so long has recently been found. The receptor will often put a lid over the molecule when it is bound, preventing it from releasing as quickly as it would otherwise. The cause of the vivid hallucinations, altered perception, thoughts, and feelings, and subjective experiences such as ego dissolution is still up to further research. Thanks for watching. Don't do drugs.